In this video, we're going to talk about the Lewis theory. The Lewis theory deals with bonding, or basically tries to explain bonding using the concept of valence electrons. What we mean by that is, let's say, for example, if we have hydrogen. Now, let's say, for example, we have sodium, okay? Sodium has one valence electron, which is represented as a little dot, okay? This symbol is called an electron dot symbol, okay? So the electron dot symbol only talks about the number of valence electrons. It only depicts the valence electrons with the symbol of the element. So sodium has one, and then if you look at chlorine, chlorine has 7 valence electrons. So that would be the electron dot symbol for chlorine would be 7 dots around it. So oftentimes the question arises, well, how do you draw these? So there is no fixed notion or no fixed convention of drawing them. You can simply do, let's say the element symbol is X, and you just start putting them one on each side, and then you start pairing them up, okay? And after doing them a couple of times, a few times actually, you will start to realize that certain elements have certain ways of drawing them and other elements have other ways, okay? So we'll kind of not worry too much about that. Okay, so we have these electron dot symbols, okay? So let's say sodium and chlorine, you have these two. If these two had to bond with each other, you can see that sodium has 1 electron out here and chlorine has 7. And the Lewis theory, it kind of works on a couple of different rules, but one of the big rules out here is the octet rule. And the octet rule basically says that every element wants to have 8 electrons in its outermost shell, so 8 valence electrons. So every element is looking for 8 valence electrons. So as you can see, between sodium and chlorine, chlorine has 7, so 1 less than 8. So sodium is going to try to donate 1 to chlorine, and sodium is going to be left with nothing outside. But if you look at the periodic table, I strongly urge you to pause the video, this video, and look at the periodic table. You will see that sodium actually has 11 electrons, okay? So when it gives away 1 electron, sodium is left with 10 electrons, and 10 electrons matches the electron configuration of neon, which is a noble gas, and neon actually has 8 electrons in its outermost shell. So if you kind of write out the electronic configuration, you will see this would be 1s2, 2s2, 2p6, and that is the outermost shell because of the 2 plus 6 is 8, okay? So sodium, by giving away its 1 excess electron, actually also ends up with 8 valence electrons. So the result of this is Na, and then we're going to, since sodium lost an electron, it's going to have 1 net positive charge, and chlorine gained an electron, so now chlorine has a complete 8 and has a net negative charge. Sodium, by losing an electron, formed a cation. Chlorine, by gaining an electron, formed an anion. Okay. Now the question is, and this is all Lewis theory, the question is, how are these going to bond with each other? Well, you have a positive charge attracting a negative charge. So a cation attracts a negatively charged ion. So therefore, there is a force of attraction. This is called an electrostatic force of attraction. So what we described out here is the concept of ionic bonds. Okay, so according to the Lewis theory, an ionic bond is a bond that is formed when electrons are transferred. Between what? From one atom to another, okay? And so what kind of atoms are involved in ionic bonding? Typically, you have a metal. So see, sodium is a metal, and then you have a non-metal. So ionic bonds are bonds that are formed between the metals and non-metals, okay? They're formed by the complete transfer of electrons. Electrons are transferred from the metal to the non-metal. Let's shift gears and talk about covalent bonds. Covalent bonds are bonds that are formed by sharing of electrons. Okay, so let's take, for example, if I have a chlorine with 7 valence electrons, with those, there's the electron dot structure of chlorine, and if chlorine has to bond with another chlorine, let's draw that out here with another 7. Now what's going to happen is, clearly you can see this chlorine is not going to want to give away 7. It's too difficult to give away 7. And this chlorine is the same story. But each of the chlorines requires 1 electron. The best way for this to happen is for these 2 electrons to be shared between the chlorines. So when they share, then you form something like this. And I'm going to depict this chlorine. This dot is from this chlorine and the upper dot is from the other chlorine. So now this chlorine has 8 electrons around itself and this chlorine has 8 electrons around itself, and both of them have complete octets. Okay, so as you can see, electrons were not transferred from one to another, rather they were shared. So which atoms are responsible for this kind of sharing? They're nonmetals. So nonmetals share electrons to form covalent bonds. Now these kind of compounds that are formed from sharing, if I kind of write this compound out, that will kind of look like this, because there's 2 chlorines, so it's written as a Cl2. This is called a molecular compound. So compounds that are formed from a bunch of nonmetals, non-metallic atoms that basically come together are called molecular compounds. So now this was a very simple case of a molecular compound. Let's take a case where you have, let's take another case where both the atoms are kind of different. Okay, so let's say we have H combining with Cl. We know what Cl looks like, and H actually only has 1 valence electron. So now in this particular case, turns out there's still sharing that takes place. So it forms, this is the molecule it forms. Chlorine has 8, but notice carefully how hydrogen only has 2, okay? And so the question arises, is the octet rule violated in the case of hydrogen? And the answer is yes, it is. So it turns out the octet rule is valid for a huge number of elements, but with the exception of a few. There are some exceptions. Hydrogen is one exception. So hydrogen loves to form duets. And a duet is simply a pair of electrons. Okay, so hydrogen just needs a pair of electrons in its outer shell to complete its noble gas configuration. So when hydrogen has 2, it becomes similar to helium, which is a noble gas. So the story behind octet rules and duets is basically every element wants to attain the electronic configuration of a noble gas. However they get there, usually it's following the octet rule, because noble gases have a complete set of 8 electrons in the outermost shell. But in some cases, like helium, there aren't 8 electrons, there's 2, and so you get there by only needing 2 electrons in the outermost shell, which happens in the case of hydrogen.